Welcome to V-Guide TV. In this part 4 video of current electricity, I am discussing about the resistors in series and parallel connection. Before watching the part 4 video, you can watch part 1, part 2 and part 3 videos of our current electricity. First thing, how the resistors are connected in series. See here, there are two resistors R1 and R2 are connected to a voltage source V. R1 and R2, if you connect it like this, the current passes through R1 can go through R2. There is no other way to go. But if you take the voltage, I can write here the voltage across the first resistor, that should be equal to voltage across second resistor. That is V equals V1 plus V2, because the voltage across first one plus voltage across second one, that should be equal to total voltage. What is V? V is IR. V1 is IR1, V2 is IR2. So I get cancelled. So we can write R equals R1 plus R2. If there are many resistors and all the resistances are same, I can write R1 equal R2 equal R3 equal Rn. That is equal to R means I can write the total series resistor Rs equals NR. Next you take the case of a parallel connection. Before going that, just check it here. I told you in series connection, current remains same but potential difference varies. You all should keep that in the mind. Series means current should be same. Parallel means you see these two are the two resistors and their end point should be same. The resistor R1 and resistor R2. If you see their end points of R1 and R2 are here, and end points of R1 and R2 is here. So it means that I'll tell a shortcut like end points are same for a parallel connection. End points are same. So if end points are same, their potential difference is same. But what happened to your current? When the current reaches here, it splits into two, I1 and I2. So I can write the total current I equals I1 plus I2. What is I? V by R. What is I1? V by R1. What is I2? V by R2. All V get cancelled. So 1 by R equals 1 by R1 plus 1 by R2. 1 by R equal 1 by R1 plus 1 by R2. Here also you take the condition R1, R2 are equal. All are equal to R means what happened for the parallel resistance? It will be equal to R by N. Shortcut equation. So I have written everything in this concise form. Very simple. Parallel means potential difference remains same, current varies. Series means current remains same, potential difference varies. And in series, equation is R1 plus R2. Parallel is 1 by R equal 1 by R1 plus 1 by R2. If N resistors connected in series, NR is the effective resistance. If N resistors connected in parallel, R by N is the effective resistance. We will see two questions here. We have taken a question R. How these resistors are connected. Okay, how these resistors are connected. So see here, in this question, if you see, looking like a series connection, but it is not a series connection because you have to check it here. What are the end points of these three resistors? If you check the first resistor, one endpoint is here A. Another endpoint is connected to D. That D is connected to B. If you see the second resistor, one endpoint is to D. D is nothing but your B. And another endpoint is C. C is nothing but A. Third resistor, one endpoint is C. C is nothing but A. And another endpoint is connected to B. It means for all the three resistors, their endpoints are A and B. First resistor A and B, second resistor A and B, third resistor A and B. So I can tell that these three resistors are connected in parallel. So its effective resistance is R by 3. Clear? Now, second question. They are given here 6 ohm, 12 ohm, 12 ohm, 6 ohm. They connect a black color lines. I just represent the connection what they are given, and it is connected to 80 volt. And this violet color pen I used to just made it as a group. If you check 6 ohm and 12 ohm, their end points are connected together. If you check this 12 and 6, their end points are connected together. If their end points are same, these two are parallel connection. These two are also parallel connection. 12 and 6 are connected parallel means effective resistance is R1 R2 by R1 plus R2. This is a shortcut equation for parallel connection. Rp, I can write it as R1 R2 by R1 plus R2. So we need not take LCM and all, shortcut formula. So I am writing 6 into 12 by 6 plus 12. That is 4 ohm for this resistance. If you check this also, I will get 4 ohm. But now if you check it like this, this 4 ohm and 4 ohm are connected in series to a voltage of 80 volt. So 4 ohm plus 4 ohm, it is 8 ohm. So what is the total current? It is 80 by 8. What is 80 by 8? That is 10 ampere current. So I got current as 80 by 8, that is 10 ampere. So you have to understand by seeing the resistor whether it is a series connection or parallel connection. Parallel connection, now you understood, I feel, their end point should be same. See the next question. In this question, I am just taking it like this. Your connections are like this. Okay, so see here, R. It means all are equal resistors. All are equal. So now I will take here what is the effective resistance they are asking. So this question, what you should do is, you check this diagram. The current comes at this point, gets splitted equally because this is R, this is also R. That current again when it reaches here splits into 2. Okay. That means that also equal. First it's a 10 ampere means first it's split to 5 and 5. Again when it reaches here again split into 2 means 2.5, 2.5. Clear? The same here from here the 5 ampere comes here and again split into 2 and these two will be 2.5, 2.5. It means this current will be 2.5, this also will be 2.5. Okay, how can I take that conclusion? Because of the equal resistance. So as the current through this R and this R are same, just now only I told if the current is same, you can take it as a series connection. So what I am doing is I am just leaving this connection and taking this little up. So it means R and R in series, it becomes 2R. Understood? This R and R together can be 2R. Top is R. This R, this R. Another one, these two are connected in parallel. So what is the effective resistance? Effective resistance I can find by R into 2R by R plus 2R, that is 2 by 3R. R into 2R by R plus 2R, that is 2 by 3R. Clear for this one? That is your R1. Again, this R1 is in series with these two R. So what will be the total resistance? R plus R is 2R. Other than that, my 2 by 3 are also there. Then down also R and R together form your 2R. Now you find your R2. So what is your R2? Your R2 I can find. These two are connected in series. 2R and 2 by 3R is connected in series means R2 is 2R plus 2 by 3R, that is 8 by 3R. Now your circuit became very simple. Top I am getting a resistor and the down I am getting another resistance. What are the values? Top I am getting 8 by 3R and down I am getting 2R. Again these two are coming parallel. So I can write 8 by 3R into 2R by 8 by 3R plus 8 by 3R into 2R by 8 by 3R plus 2R. That is 16R square by 3, that is 16R square by 3 by this also after taking the LCM and adding we are getting 14R by 3. 3 cancel, RR cancel, 16 by 14R. That is 8 by 7R. So how we are doing this question? I understood that current through this R and current through this R are same. So these two are series. I made it like this. After that these two are coming in parallel. I got an answer. Then the top all are in series. I got another answer. 8 by 3R. Then that R and the down 2R are in down 2R are coming in parallel. So what are the steps? 1, 2. This is my third step. And this is my last answer. Okay, check it. Leaving the connection, these two parallel R1 we found. Then this total, that is your R2. Then after that, that and the down, that is this one, it's parallel for this. Last my answer is 8/7R. So in short, I want to tell only one thing. For a series connection, your current remains same. And for a parallel connection, potential difference is same. If you want more videos, subscribe our channel, V Guide TV. Thank you.